Both UDP and TCP rely on the notion of sockets. So a socket is an OS level thing, a system level thing that is the abstraction for different kinds of communication channels. In the type system in C, a socket is just an int, just like file descriptors. In fact, sockets and file descriptors overlap. So file descriptors are things that have a file-like nature, this stream of bytes. And TCP is both of these things. It's a socket in the sense that it's a network connectivity abstraction, but it's also a file descriptor in that it's a stream abstraction. On the other hand, UDP is purely a socket concept. UDP doesn't have this stream notion because packets get reordered or lost, so it's not in the overlap there. And both UDP and TCP, again, are in the space of IP sockets. There are some other protocols inside of IP, like the ping protocol, but almost everything is UDP, and really almost everything is TCP. What this overlap means is that TCP socket/file descriptors, they will work with a larger subset of system calls than UDP, which only work with the socket subset. To create a socket, in contrast to a file descriptor where you always have a particular source, like a file or a pipe or something, the API for sockets is at first you create the socket and then you connect it to something. So the socket function creates a socket. You have to say what kind of socket, how you're going to use this eventually when you create it. So the domain is a family of things like IPv4. The type is something within that protocol family, so UDP or TCP, and then protocol is even more specific kind of subtype. It turns out to be irrelevant for UDP and TCP, but fortunately we don't have to worry about these three different things and all the specific constants that go with them, because when we get an address from getAddrInfo, it has fields that we can just send on to socket. And then, once you have a socket, you can bind it to a particular address. And binding means connect that socket at the current host to a particular port with its protocol. So we take the socket that we created and the local address that we want to connect it to, that we want this socket to represent. So adder here is always the current machine's address in some form. It could be any of the different interfaces, like the loopback device or the Ethernet card, say, or it could have kind of wildcards for those. And then the length is just specifying the length of this representation. Right? Whatever getAddrInfo told us it was, we pass that along. After a socket is bound in this way, any other process, perhaps on the same machine, perhaps on another, that knows the address that includes the port number there, where the socket is bound, it can send a message to that socket.